And we're live with our 144th episode of Absolute AppSec. I'm Seth Law at Seth Law on Twitter, joined by my lovely co-host, Stefan Edwards, Logical on Twitter. Stefan, say hi.
Hey, everyone.
And you might have we might have got a little bit of the pre-show banter going on before I started. I pushed the button and did give Stefan a good, Well, I gave him notice and he just ignored it and kept talking.
Yeah, as usual. As per usual, I like to live dangerously.
Yes, we all do. I'm excited for today. Our prep probably didn't go as well as it could have. Getting ready to talk about the fuzzing tools that are out there, but we do have some examples to show you, some stuff that Stefan and I do when we're dealing with lower level applications, right? We're all familiar, and I think a lot of people that listen to the podcast are familiar with Burp Suite and the fuzzing that is done by Burp Suite that is very targeted to specific exploits, whether that is cross-site scripting or SQL injection or request smuggling and other things that go on with web applications specifically. And this goes back to my days back in school. And I know whenever you're on the podcast, Stefan, we talk about edge cases, we talk about fuzzing, we talk about some of these other tools that exist. And I don't think it's in general use. I mean, I know at some of the orgs that you've worked at, you did go down to that low level, but in general, across our industry, it's not as prevalent. So, I mean, your thoughts on that before we dig into some of those tools?
I think it's not just our industry, right? Like, folks are not using property testing to extend their unit testing. I talked about this a few times in Absolute AppSec.
But let's slow down a little bit because you and I both understand what property testing is, right?
Sure.
I do want to define a little bit of this as we move through it today because we throw those terms out, and even at times I know that you get a lot of shit for it, right? But the fact that we have to Google what it is in order to understand. So awesome. Yeah, you threw a link up there. Let me copy that in and drop it into the actual show notes.
But I think the easiest way to think about property testing is to think about it like unit testing with data that you don't necessarily know and control. So for example, let's say you have some bank account and you want to make sure that all transactions never go below zero, right? And so folks are making withdrawals, they're making these sorts of things, and you're like, yep, our unit tests look good. We whenever you pass in a integer, we never go below the value of zero, or we never go above a certain threshold. And as you're generating these tests, you're thinking through all the things that you might consider. But when you get into fuzzing, when you get into random data from users, that sort of thing, you're really looking for things that invalidate your assumptions. You're looking for things that break the way that you've modeled the system. And so you might have someone who makes a deposit of negative $10,000. Or they make a withdrawal of negative $10,000. So instead of subtracting $10,000, we end up adding $10,000 to the user's account. Now, that might sound ridiculous, but this is actually things that we've seen in, especially like cryptocurrency space, in smart contracts, that sort of thing. These sorts of understanding of what users and what data you can actually process is very difficult to fathom from a single set of, this is what I thought through, everything is fine. And so property testing, like fuzzing, generates random data, where property testing is slightly different from fuzzing and much more towards the academic definition of fuzzing, is there's some sort of invariant that you expect to hold the entire time. For example, that your balance never goes below 1,000, or it never goes below zero, or you can never add, you can never withdraw a negative number, that sort of thing. And property testing is the combination of unit testing and fuzzing itself, or random data generation, really.
Yeah. So I mean, the way I always think about it is there is some invariant. So there's some property that has to hold true no matter what happens to the system. And so when I fuzz, I'm throwing everything and anything at it. Like I'm throwing the edge case of what I expect, like on the edges, as well as, hey, there may be some other functions that are being called that affect this property. And then every time that you throw something at it, you check that property, you check that invariant to see whether or not it still holds true. And if it does, this is where we get into the whole mathematical idea that you can mathematically prove that your application is secure because it can handle all of this property testing, all of this fuzz testing, and it still exists in the state that you expect it to exist in. The second that it doesn't, then we have problems, right? Whether the application freezes, whether, and there's all sorts of properties that we can test against. Defining what those are is somewhat of an art, but most applications that you look at have properties that are inherent to them. That's the functionality that they're expected to provide to a user or to a server or whatever else. And so it's fairly easy. Like once we start thinking about programs in that paradigm, you start to realize how little testing we actually do when we're performing something like a penetration test. Yeah. I mean, just in general, like sec lists, right? It's, yes, there might be 10,000 different parameters or different cross-site scripting payloads that we throw at an endpoint, but that's such a limited space to some of this random testing that's out there and the property testing that we should actually be doing to ensure that our application is inherently secure.
Yeah, and I think this is something that's been really good in the blockchain space is and I know there's like good and blockchain in the same sentence is probably oxymoronic to most folks, but there are certain things that have been much better in that space. And one of the things is understanding all of the invariants, all of the properties of your system. And as security researchers, security testers, auditors, whatever nomenclature you use, understanding and extracting those properties and then testing over those expected properties is something that you'll see very common in the blockchain space that I'd love to see replicated more in the traditional security space there.
Yeah. I mean, as a consultant, the issue that I always run into is the timing aspect, right? Mm-hmm. The fact that they want some sort of a security test done within a limited time frame. And I know we're going to get into this more today, but doing proper property testing and full scope fuzz testing is not a quick process. It's not something that happens in a day. It's hard to communicate that to clients that are just concerned that their application doesn't accept negative money, right? Like that, hey, we want to really prove out that this is secure, and then it's your whole stack, not just this custom stuff that you wrote. It's just a hard sell is what I run into from a consulting perspective.
I think the other thing that's very difficult about these sorts of processes is you might shake out the trivial bugs very quickly with a lot of generals dumb fuzzing, but until you move into actual property testing, actual constraint testing, actual understanding the state space of your program, it can become very difficult to shake out the truly novel bugs for a lot of these sorts of things. And that's what actually takes time. Yes, you'll find places where you accept an integer and lol, it's negative. But finding out that there's a 10-step data flow process, and actually step 9 will process something in a weird way that you entered in step 2. Modeling that entire process is extremely difficult, and that's where I think most of the time for these for actual fuzz testing, actual property testing is the difficult part that most people don't really seem to understand.
Yeah. I mean, and that steps through to we always talk about kind of this business logic testing that we do in applications, and that's realistically what we're trying to build fuzzing on top of. It's not just this single request response. It's exactly what you're saying, like these multi-step processes that all right, you change something in, step 1, step 8, and it causes step 10 to give back data or to crash. there's certain conditions that have to exist for all of this to happen. And yeah, anyway, it's just a difficult, long process when it really comes down to it. And business, depending on where they're at, may not have the appetite for it, right? It just, and so we've developed these shortcuts. We've developed sec lists. We've developed, Burp Suite, the way that we do that testing. We slim it down to specific unit tests and specific components, and that's all that we look at. And that may catch 80% of the bugs that are out there, but that other 20% can be pretty devastating, and cause all sorts of issues. So
yeah, and you also have the potential for state space explosion. Basically, there's so many potential paths in your program that it just becomes untenable to understand all of them, especially if with the greater the level of dynamicism in the application, the greater the difficulty for narrowing down what paths are actually there. There's lots of academic papers about how do you do program analysis on very stateful programs and on very dynamic programs, and it's not a solved it's not a solved issue at all. There's all sorts of like chopped symbolic execution and chopped program analysis papers out there that you can read to try to figure this stuff out. Where clients come into concern, it's really interesting to see clients who have excellent unit tests. This is where it shines. When clients have excellent unit tests, they have excellent invariance, they have excellent understanding of their program space or what it's supposed to do. It has some spec or something there. That's when it's very interesting to start to fuzz, because you can say, okay, we know the baseline is covered. Let's start to generate some random data here based on some seeds and some good corpus management. And we'll probably talk about all of that as we go through. But making sure that we generate more would be super helpful and super useful there, and that's where fuzzing and other techniques really shine.
Yeah, and I'm wondering how much more we need to go into that, but it's a fascinating space, right? I mean, honestly, I remember taking way back in college days, my initial like software testing course, and getting into like all of these types of all of these concepts, right? And at the time I was like, oh, software testing, this is going to be the most boring course that I've ever had. And I still own that book, right?
Yep.
Because it really hasn't changed that much when it comes down to it. Like, I mean, we're talking 25 years ago, and the book was probably written in the late 60s. Mm-hmm. And the principles that exist in there are what I have done over the course of my career, but in a limited scope, right? I thought it was going to be, typical, like what we think of as a typical QA test. Oh, like go in, make sure that I can put my name in here and it's accepted, and then I move on. And that's not at all what is actually going on under the scenes when you talk about property testing, when you talk about fuzzing and the edge cases, and thinking holistically about the space that exists and what you're trying to test for. And then when you change state, how do you validate that again and again and again? I don't know, like you started talking about, the state changing and how complex testing gets. Like even the books by McGraw, like what is the one that the Fortify guys wrote?
The McGraw Secure Programming with Static Analysis.
Yep. I mean, even that is excellent, right? Like, because it goes into building an abstract syntax tree and what goes into it. He's going to go find it there. I'm pretty sure mine's right up here too.
Yeah, I have it. I also have this, which is on my next to be read, domain modeling with function made functional.
Uh-huh.
It's all on domain-driven design with F#, but if you have any sort of like compositional or like data-oriented programming background, it's relatively digestible from what I've seen. But yeah, honestly, a lot of the stuff that you talk about in fuzzing and a lot of the stuff that you talk about in property testing, Rabbit, RA6BIT, and I have joked before, like, most of the stuff that we do is just really shitty, like QA and
It is.
QC. Most of what we're doing is just like, oh, we're trying to generate test cases that fail. Like the QA people at every large company are way better at this than any pen tester that I've ever known.
And their tools are so much better than
yes.
I started, I mean, back in, that was it, right? Like at some point I had this revelation, and I know I like to say it too, that pen testers are just, really shitty QA testers that do it poorly and don't document as well. But when I was first working at the bank, that's when I realized like the things that I was doing corresponded very specifically to the security testing or the software testing stuff that I did, and starting to talk to the QA testers and how they do and the tools that they have, the load runners and other things that exist. Like we still have this disconnect that we don't use them properly from a security perspective. We don't write security test cases very well that they can then go in and run against the application using those tools in a manner that we could probably spit out more better results, right? Than we currently do. Yeah.
I think the other thing is, and Bobby has said this. Bobby is the one who gave me this phrase. He was on the podcast when we were talking about Kubernetes, but Bobby has this notion of like, what do you do when you have an application that has 100% test coverage? Like the application has 100% test coverage. Every line of code is covered, so there's no security vulnerabilities in there, right? And it's like, well, no, there's a whole sort of there's a whole aspect of testing, and you can find things that, yes, it technically covers 100% of code, but that doesn't mean that it covered 100% of search space within the entire application's data flow. Yeah. And there's all sorts of things you can do there. So
100% of the state changes that go into an application. It's a massive amount of data. It's a massive amount of headspace, right? And computing space to think about, to actually ensure that everything is covered and there's no one edge case that's going to break your application 10 ways to the sun, right?
Well, I think a good portion of this as well is that we're not, as security people, we're not used to thinking about us actually doing program or system analysis. A lot of the approaches that we have are unsystematic, or they're just like, I'm going to run through the things that I need to do for a pen test, or I know. And it's interesting. We're thinking about these things, like you said, we're thinking about these like QA or QC people, but we're not approaching them with the same systematic like approaches and tooling that those folks have. And we're not really trying to understand the entire space of things, like weird machines or anything there. Mm-hmm. We're just sort of like throwing stuff from sec lists or whatever, Daniel Messier puts together for us. And then we're like, or Sputter. And then we're like, oh, the tool is here. Let me tinker with this stuff. And then we come up with a proof of concept, and that's it. When in reality, there could be 10 other things that we're missing right in the same area, but we're not doing a systematic approach to these sorts of things. We're sort of just, kind of blindly, moving through the dark there and finding things.
Yep. Yeah. Well, I mean, on that note, maybe we should talk through Radamsa. Maybe we should show it right before, we go 20 minutes and ranting on security testing. For the two of us, right?
I was looking for the image that I drew a few years ago of like, this is what property testing versus fuzzing versus everything was, because I do think that is, that is super useful to show, but I do agree. There's quite a bit of a different understanding on how these things operate that folks are not used to thinking about, really.
No. Yep. And I don't know. I don't know how much of this we need to push into the security space either, because this has worked for us for finding these vulnerabilities. But then, so I look at the research, right, that James Kettle has recently done on HTTP2, and right, it's very targeted, but it is expansions on like our current knowledge set and our current like fuzz lists from sec lists or whatever else it is that we're looking at for very specific vulnerabilities and exploits. And I really think that there is just such a wide array of other things that we're not catching when it comes to protocols, when it comes to applications, when it comes to TCP, stacks, that I don't know how we can actually move that needle forward.
Well, I do think approaching it from a very different direction is basically all we can really do here. A lot of the testing, and we can get into this, a lot of the testing that we're doing is so focused on one level or so focused on things that we've already seen. We're not used to having this sort of like random element in a lot of the testing. It's also funny because I guarantee that if anyone is into vulnerability research or exploit development, they're all like, of course we all do fuzzing. This is like, I think Google, like Project Zero was basically hands on keyboard was like 50% of what they found. And then fuzzing was like 25% of what they found. And then other techniques were like spread across the remaining 25% of what they did. It was like, but we don't think of it that way. Most people don't approach things and be like, all right, how do I generate fuzz tests? How do I expand upon what I'm doing here? It's just sort of like, let me throw some stuff at it and see.
Well, and I mean, part of the reason that works is, I'll be honest, right? Most of the apps that I run into have very poor unit test coverage, right? Like they may validate, one input and output of a function, and then that's it. If they have any unit tests for an entire library that they've developed, the tests are basically, hey, did this work when I ran it in AWS? Right? That's the level of testing that goes into a lot of these applications, and so finding those edge cases ends up being a fairly easy process, right? Things like insecure direct object reference and like cross-site scripting. Yeah, I mean, those checklists work because we just don't have the coverage as it is in most of those applications. Now, like you're right, like you step into the cryptocurrency space, some of these other spaces, there is better test coverage. And so you're having to do some fuzzing, you're having to do more. Some of the open source projects that we depend upon heavily, they do have fuzz projects listed up and the whole like, so there is stuff that's out there, but it's so few and far between, unless I'm wrong, right? Like, but this is what I see coming out of business is just a complete lack, an utter lack of basic unit tests, and so it validates this testing pattern that we have for security testing that probably wouldn't fit if they actually did the basics of security testing as they should.
Yeah. Can you see what I'm displaying here?
Yeah. Let me add it to the stream really quick. There you go. Yeah, let's see if we can zoom in.
Perfect. I can zoom in.
Okay. Yeah, you got it. There we go.
Yep. Yeah. Yep. So, I mean, like, really, you can think of a program's domain as sort of like, a set of inputs and a set of outputs here on the axis. And ideally, we would know exactly the square that we have, this ideal space here. And, we would know exactly the area under which our program operates, and we would know exactly what input maps to what output. And then there are sort of like different tests and different styles of testing that folks do. If you think about the traditional dev model in the like late 70s, early 80s, the 90s, it's sort of like, yeah, I know exactly what I'm doing. And it's like you maybe have these like test points that but you don't really know what's going on in here. And if you think about like traditional unit testing, it's sort of like you have all these weird angles. They maybe cover some of your program domain. They maybe don't. You don't really know. There's no real like process and understanding of these things, but we sort of get a rough outline of what our program is meant to do and what we expect to do there. And what we're talking about today is this last one, where it's like you sort of scattershot throw random stuff. And through that scattershot approach, you roughly start to understand what is the domain of your program. It's not necessarily crashes that indicate these, but it could be all sorts of odd behavior, behavior that folks don't want, that fuzzing allows you to finally determine what the actual shape of your program is. And then lastly, you have like higher level techniques, abstract interpretation, symbolic execution, other sort of like bounded and unbounded model, temporal logic, etc. But there are all sorts of things that then you can automatically determine, but they're obviously more difficult to set up. They're obviously not 100% the ideal case either, but they will automatically detect some of the things that you expected as close as their model can. So this is what really the basis of this. This is what Seth and I are talking about. It's this sort of testing that we'll be talking about, especially fuzzing today. This is always useful when I'm like trying to explain this to students and whatnot. Like, hey, these are the types of testing. These are what is there. It's also hilarious because I drew a graph to show like what we're talking about here for a lot of you.
No, but it is helpful, right? Like, I start to think about Venn diagrams on what's accepted, what I expect to be accepted, what actually is. But it's that same idea, that scatter shot. So with that, let's talk about Radamsa a little bit, right?
Yeah, I think honestly, I know people smarter than I will probably grimace at what we're about to mention here. But honestly, when I need to fuzz something, I usually start with Radamsa. It's a very simple mutational fuzzer. Basically, it takes its input and it mutates it. It randomly modifies some portion of that input and then outputs it on the other side. That's literally all Radamsa does. And you can tune the seeds, you can tune the mechanisms by which it does these sorts of things. But at its core, it's just a mutational tester. It just literally takes input, does something to it, and then outputs it on the other side.
Yep, and I do have it up, so I did want to show, because you start to see where it becomes interesting, because it makes no assumptions about what the accepted space is.
Yep.
Right? That's the problem that we run into as humans and as developers, is we make these assumptions about what user input looks like, and then we throw that at the application. It responds as expected, and we move on, as opposed to something that's just, hey, I'm going to take that input and I'm going to triple it this time, and then I'm going to 100 times it, and then next time I'm going to remove half of it, or I'm going to add integers, or I'm going to whatever. So, let me actually show.
And while Seth is setting that up, it is funny and notable, to quote Bobby, it is notable in that we've actually used Radamsa plus Wireshark to find a single packet DOS in commercial projects just like, a few months ago. Like 6 months ago, we literally found a single packet DOS in something that is 30 years old now?
Yeah.
And it's like been picked over, it's been tested. It's not like this is some, fledgling product, or it's not like it's something that is super obscure. It's fairly well tested. And yet with Radamsa and some packet inspection, we were able to find something super trivial that would DOS a server.
Yep. And so here's a simple, right? Like, yeah. Like I'm gonna send hi absolute AppSec to Radamsa and tell it to just give me some output, right? Change it in some way. Whoops, I forgot to.
Quotes help.
Quotes help. What did I do there? Yeah. Oh, that's because I put a bang in there. Huh?
Yep.
Right. Okay. So it changed something, right?
Well, no, it can mutate and just literally do nothing. Like change nothing.
So let's do 10 changes, right? So over time, and you'll see a seed. The nice thing here is it's repeatable, right? So as long as you output that random seed and you pull it, you can have it generate the same input every single time, right? So you'll see it took absolute a whole bunch of times there. It changed it up to AppSec. AppSec, it's removing things, it's adding characters, it's deleting them, and you can just have this run infinitely and generate infinite number of test cases. If you think about the graph that Stefan showed recently, right, like all those scatter shots that we're putting in here, it's exactly the same idea that we're changing things up to see what's going to happen. Now, I'm just running this into the browser or into the command line right now, but Radamsa does have the option to actually push that output somewhere else. So let's see. Yeah, I've got a couple different. So here's a GET request, right?
Yeah, it was a GET. The other thing too, saving the seed is very useful, because later when you find, like when Seth and I found that single packet DOS, we literally replayed the seed and replayed the count. It's just a pseudo random number generator. So we just said to Radamsa, hey, we saw it crashed at, number X. So here's the start space, and just play number X for us. That's it. We don't care about anything else. And that's how we started to tune down our single packet. Was just literally from Radamsa, give me, like, play it again.
Yeah. And the thing is when it came down to it, actually finding that DOS, right, that single packet DOS in that app, it took a little bit of time, but it was mostly, how do I interact with the application? Okay, now how do I use Radamsa to actually modify that request? And once we had that packet and we're able to send it over and over and just let it do its thing, it was so reliable for hitting that hitting that DOS, that we were able to find it multiple times through different avenues and through different.
Oh,
yeah. I mean, it basically happened all over the place is really what it boiled down to. We just pulled out one single instance of it that was replayable over and over again.
The useful thing there is also just corpus management. Honestly, understanding and curating the sort of random data that you generate is incredibly useful when you're doing this sort of testing.
Yep. So I mean, I did want to show it actually spiking against a running application. So I have VTM, which is that vulnerable task manager that we use in the course and that we've used for years. It's just a Python app. But the interesting thing here is if I run this, it's running on localhost port 8000. The testing that's going on, while it might hit that level 7, like the interactions with the backend kind of Python Django code, most of it is probably going to do more with, if you see the top window here, most of it actually has to do with how the protocol is being analyzed, right? So what's being accepted by Django, like under this managed server, right? The debug server that we're running, and whether it can actually handle the requests that are being sent by Radamsa that have been changed and aren't what is expected. Let's see, it's the wrong one. So let me give it a shot here. We'll send, let's see how many. Yeah, that's an infinite number. But let's send, okay, so 50 requests. Let's take just a GET request to VTM. We'll modify it 50 times and see what actually happens. All right, so it looks like it did a whole bunch of them before it actually started to air out, right? So a lot of those were just accepted and, it didn't send any sort of a response. We only got one crash in there, but we don't have a lot of information of what's actually happening behind the scenes. We don't have a debugger hooked up to Python right now to see where it's actually dying, but there is something in Socket Server that it can't actually handle this in base HTTP because it's not speaking a proper format. Now, if we run it again, go ahead.
Oh, I was going to say, if you wanted to actually debug this, one of the things that I've done in the past is change the output port, use the same seed, and just write it to a local file, and then replay each of those from local files to see which one causes the crash, and then use that generated corpus from Radamsa to say, start to actually narrow down what I'm looking at here. That's where this becomes useful. We can generate a bunch of crashes, and then if Seth scrolls up, we can see the seed that's there and replay that exact seed that Radamsa started with. And now we know, okay, we have this seed, this causes a crash. Now we can start to iterate from there and start to actually break things.
Yeah. So you'll see that. So if I do that -s and that seed, so that was the seed that was there, we pass it back in, and it looked like it crashed further on, right? So let's jump a little bit. So instead of doing 50, let's do 20, and we'll do we'll do a -s and seek our way 40 into that, right? And see if we can get that same error. And maybe we did. Yeah, we did. So we got that same error again. We could easily, we can start to filter that down too, right? So maybe let's see if we only do 10 of them. And if I'm not saving it, did that actually pull? That was one of, yep, it did. So it did it on 10, right?
Yeah, and this sort of filtering process is really all you need for a lot of these assessments, or a lot of the work that we end up doing. It's like, oh, there you go.
Yeah. So at 5, so at that point, right, I can just look and see what it's actually doing here, and we can see if we can figure out. So there's only 5 of them. One of these that's being sent, whether it's the -1 or one of these
HTTP 1.34.
Yeah. I mean, it's doing something that Django obviously doesn't like here, and causing some sort of a crash to occur. I mean, and we could keep this tuning process going on. But this is exactly how we found that DOS, right? Is, hey, let's just throw something at it, narrow it down until we figure out exactly what it is. And in that case, it was repeatable, and it caused a full application server seize up. This is probably not the case here, because there is multiple threads, they crash, and they've got like management going on. But it's still dangerous, right? Like, this should be handled by the socket, right? Like, we shouldn't be accepting a -0 or, whichever one of these is actually causing the problem. And it might be this double get in, packet 47 there, or 48, right? Like, one of these is causing something to go on. So.
And these are not test cases that any of us would actually want to or think of writing by hand.
Yeah. No.
For something incredibly, and I was just responding in Slack there, but there's multiple different fuzzers that you can reach for. Like Eric was saying, they use libfuzz quite a bit. Libfuzz is extremely useful if you have source and you want to wire up tests. GoFuzz, both with and without a hyphen, since there are sadly
two different
conflicting names there, but GoFuzz is super useful. Gopter is super useful as a property testing framework. There's just a lot of stuff that's in this space to actually check invariance and check these sorts of tests and see what actually causes crashes here. But most of what you'll end up doing when you're doing these sorts of tests are corpus management. Most of what you're doing is just finding the things that crash, sorting through the haystack for a few needles, and then making sure it's repeatable and reapplicable.
Yeah. And that's where I've run into problems. Actually, like when I first started doing fuzz testing, that was the biggest issue that I had, was making it repeatable, right? It's really easy to throw crap at something just randomly and have it crash, but being able to do that reliably so that you can then, number one, either build an exploit, turn it into some sort of a CVE, right? To be able to do that, you've got to be able to repeat it. And this is very much in the vein of the security testing that we do, right? Is we find a vulnerability, but if we want it actually fixed, we have to tell the developers how to recreate that vulnerability. And so it is that corpus management. It's knowing, okay, this is what I was running. These were the inputs that I gave it. So for Radamsa in this case, and this is the output that occurred. I can turn that over to a developer, or I can throw that into a GitHub issue and have it actually repeatable so the developers can fix it. Right?
I think the worst thing that I've ever run into in these as well is you're fuzzing something, you think you have established what the bug is. Like Seth was just tuning down the corpus, it was clearly somewhere between 45 and 50. The worst is when it's actually the interaction of the entire stream of things. So one other thing I've seen with these is like, oh, it looks like it's crashing around 45, but actually the thing that set it up was, 20, and the entire chain needs to exist. So finding that sweet spot of what actually caused the crash can also be very difficult as well. And then doing test case minimization is very difficult there at times too.
And that's just it. Not the only thing that we're looking for is not just a denial of service. It's not just that exploit, but it's the chain that leads to it.
Mm-hmm.
And then when you have to take into account the full state of an application, right? It becomes like, again, corpus managed becomes so important to know. Hey, for me to get to this actual crash, these are the conditions that have to exist. I had to log in using this parameters. I had to set my password to this specific, string. And then when I did a change password, it caused this X, Y, and Z to occur. Figuring that out is, while it can happen randomly, right? Like we're seeing, it may or may not be a single packet, right?
Right.
I think that's what you're getting at. So
yeah, I mean, I had a customer with a custom format. That's the easiest way of saying it without violating NDAs. They had a custom format, and it was quite small. It was, bytes, maybe at most like 100 bytes. And when I actually pushed corpus or corpora of crashers, I was somewhere around 300 megs for each corpus that I was pushing up to this client. Now, we had individual test cases that we were pulling in. We had individual things that we were highlighting for the customer. But the full corpus was orders of magnitude larger than what we were actually testing normally, right? And again, as a security tester, you're not going to necessarily think of like 300 megabytes worth of data to generate here. The tooling is what's really the force multiplier for a lot of this stuff. And it was, to start, largely Radamsa. I largely started with Radamsa to fuzz things, found some crashers, and then I wrote smarter fuzzers based off of that format and based off of the crashes that we were seeing there.
Yeah. Yep. And it makes sense, right? And that's what occurs is, yeah.
I also think the other thing that's interesting with a lot of this is fault injection. It's another technique that folks are less used to. But very often we assume that file systems, we assume that networks, we assume certain things about our environment work a certain way. And they often don't. But we have trouble modeling these things, and we have trouble actually understanding where these touch points are. And actually finding those and actually like uncovering those issues is very difficult, or it may not even be possible with a normal setup. And fault injection is extremely helpful for a lot of these things. Trail of Bits has KRF, but there's quite a few other fault injection systems that you can use for a lot of these sorts of things. Basically, making a fake file, and there's lots of fake file system testers. They're probably one of my favorite areas to do fault injection, because we always assume that the file system is doing what we want it to, and very often it's not. Very often the file system does not care what you want or who you love or any of these sorts of things. It will murder all of those assumptions. So
yeah. I was just going to post up a link to KRF there since you mentioned it. Let me turn off it in there.
Yeah, there's some really interesting work in that space, but file system fault injection is really interesting. And then obviously you get into things like hypothesis, like quick check, like the Go fuzzers and things like that at the application level. And you can run the gamut from source code that you've stolen or source code you have access to binaries. You can lift binaries into representations and do fuzzing there and invariant analysis there. And then also just go from network level, right? You have no access to this thing. Let's fuzz the stuffing out of it and see what happens to it.
Yep. Yeah. And I mean, it's useful to be able to attach a debugger to things as well, right? Just from a determining where it's going on or what's going on and where things are actually crashing. obviously anybody that's in exploit development is probably doing that, and they're doing that at a kind of a deeper level than we are here. It's this, this example that I show is very, very simplistic compared to what's, the, hey, I'm looking for an exploit in Apache or or some, large open source project. There's a lot more tooling that goes into it, corpus management, and nuances at times that you can dig into it. But this is a good place to start, right? If you've never dealt with it before, it's interesting just to throw this even at the applications that you're testing through Burp Suite, right? And I believe, isn't there like a libfuzz plugin for Burp Suite, if I remember right?
I don't know if there's a libfuzz, but there are a few different fuzzer techniques and a few different fuzzers for Burp Suite itself there. Libfuzzer has quite a bit of useful compiler infrastructure for testing things as well. If you're doing work in Rust, libfuzzer is really good for that. There's a lot of support for testing your programs that way and making sure that you're covering all of your test cases that way too. Also, since we're on that topic, Antonio, I sent the link to you in private chat here, but Antonio Morales at SecLab at GitHub, he actually has a Fuzzing 101 class, and he's taking actual CVEs in actual open source software and helping you to actually process those and understand how they were found and how you can find them with fuzzers like AFL. AFL is a coverage guided fuzzer. I know I'll probably catch flack from a few friends for that one, but it's effectively a coverage guided fuzzer. It looks at the tree of your program and attempts to find paths that it hasn't covered, and then generate output that matches those paths. So it's not quite a dumb fuzzer, but it's also not some of the smarter techniques that we see in other areas there. So it's super interesting to see how a lot of these bugs are found, and a lot of these sorts of things actually impact open source software. And Antonio's class walks you through that. Yeah.
And I mean, honestly, Antonio's like that, those modules that he's building out in there are very similar to what they'll do in a Black Hat course or, on exploit development or fuzzing. Like learning how to fuzz is, can I recreate this vulnerability? Can I recreate this exploit, how it was actually found in XPDF or, whichever one that they're looking at there. If you're interested in it, that'd be a great place to start. It's not necessarily a 20-minute thing, right? Like my little example here. It does take some time to get everything set up and working. And that's part of what I wanted people to understand, is that it's not like understanding the application and how it communicates and how to communicate with it is half the battle when trying to build these or to fuzz any application. Because if we can't communicate with it, right, it doesn't really matter what we do with the fuzzer or what we send to Radamsa, because it's garbage in, garbage out. We do want it to be fairly concise so we can keep track of it. Otherwise, we won't be able to recreate it.
And the other half is violence. But Antonio actually has this really great diagram here on what the entire workflow looks like. I very often had to recreate these sorts of things, but it's a very good graphical overview of how do we generate an input corpus? How do we mutate these sorts of things? How do we take crashers and add them to areas to say, code coverage is increased, or we've increased some other area of the application that we hadn't seen before? And how do we keep that feedback loop going so that we do have new data, we do have new stuff that we want to share? This is a great representation of the sort of corpus management that Seth and I have been mentioning this entire time.
Yeah.
It's also just generally an interesting class. We've been following along with it. It's been great, and he's been doing good work. But it is nice to see it, because usually when you take these classes, it's like some ancient version of something, or it's like some code that they tell you to compile with, fpic turned off and stack canaries turned off and all these sorts of things. Whereas it's like, no, we can actually find reasonable test cases and reasonable crashes based on actual software that's out in the wild right now. And here's a CVE that we're demoing.
Mm-hmm.
You know?
Yeah, well, I mean, look at those CVEs that he's actually got in there, right? They're what, 2019? Yeah. Well, I guess the second one, that libxif, is from 2009. But that first one from XPDF, I mean, 2019, that's got all the modern, protections built into it, right? And so, yeah.
Well, and also he's showing the tools that you should be looking for if you're trying to do research on binaries, AFL fuzz, Clang, that sort of thing. And then you obviously can extrapolate from there on the sort of interesting test cases or other areas there. The techniques are useful for any sort of fuzz testing you would want to do.
Yep. Yeah.
Did you want to chat through that GLIBC?
Yeah. Let me share that. I mean, we like I said, we've only got 8 minutes left.
Well, I think
obviously Stefan and I can talk about this for a long time, but
well, yeah, I think it's useful just to understand variant analysis, right? And the reason why we're harping on these things isn't because we want you to find cooler bugs and new things. It's that it's a new tool to really, end up with a different set of analyses and a different expanded set of analyses here too.
Yeah. And I did notice, I knew it was out there, but I haven't actually used it a lot. There is a burp extension for Radamsa. So you can use that as the fuzzer for, sending data to an application, which could end up in, even more interesting vulnerabilities. So you should add this to your repertoire of testing tools, even if it is just to see how the application responds. It doesn't mean that you're necessarily going to get something out of it from a security consulting perspective, but it will push you to learn more and more fuzzing techniques that will be useful down the road.
I'm just moving because the dogs decided to start barking right now.
You're fine. So let me pull up this article, and then we can start talking to it. I'll share it here. I did drop it in both spaces.
Move into my son's room and see how this goes.
Okay. All right. So this was the recent one that popped up, right?
Yeah, it's super fascinating, right? Because GLIBC, if you're not familiar, the GNU libc has had all sorts of warts and has had all sorts of issues here, and it's interesting because we base a lot of our software off of GLIBC, and this isn't to blame open source maintainers, but it's like maybe if we had done a little bit more variant analysis or really like dug into this, we would have been able to see like, oh, hey, the expanded patch actually introduces another vulnerability or actually introduces a different issue here that we need to break down a little bit.
Yeah. Well, and I mean, the first one, right? Like, I think the rating on this was fairly low. And that's what it was saying, right? Like, yes, there's an issue with this MQ notify function.
Use after free, which we're still battling with in the year of our Lord 2021.
Yes, but then so this one came out June, I think it was. Is that what they were saying? Yeah, or July. And then we've got this one, which actually, null pointer dereference. Yeah,
which is again, these are sorts of techniques. In fact, one of the things that Seth and I were originally talking about to demo, I don't know, Seth, if you want to pull this up, but ICOS can really help with a lot of these sorts of tests. ICOS is not a fuzzer; it's actually an abstract interpreter. It has a certain different technique. It models interactions with C and the system, so it's slightly more. It's slightly more intense in how it does a lot of these things, but ICOS can actually uncover quite a bit of issues with source code and with systems based on the model that it has. So without really executing code, it does. There's a bunch of asterisks next to that, but without doing a lot of the sorts of techniques that we would normally have to do, an abstract interpreter can find a lot of these vulnerabilities just simply by having a very good model and see, hey, this looks like it could lead to use after free, or this looks like it could lead to a null pointer dereference, because out of the 10,000 paths that I see this application running through, I found this one path over here that it doesn't seem like you would normally ever hit it, but that one path does not actually, check that we have a null pointer here prior to. And it's
and I mean, honestly, we should demo ICOS at some point, right? Obviously we didn't get it together for today, but we will, and maybe we'll just do a quick demo on it and drop it up on the YouTube channel at some point.
Yeah, that'd be interesting. I mean, ICOS is something that I've used quite a bit. In fact, if you have used an abstract interpreter, if you've ever used Splint before, if you're interested in reading about this sort of stuff, Splint, yes, the source code, the security, lint for C, Splint actually has a lightweight abstract interpreter built into it, and you can set all sorts of invariants that you expect to hold, and Splint will try to invalidate those invariants based on its abstract model of C.
Mm-hmm.
So it's super interesting for those sorts of techniques if you're curious about this sort of stuff.
Yeah, I would encourage people to jump into AppSec Slack or other places to talk about these. I would like to drive that discussion a little bit further on how that's actually used in kind of this commercial or prod sec space that you and I play in. I mean, I know you're doing more red team stuff at this point, right?
Mm-hmm.
But I don't know. It goes back to the whole sputters talk that I gave, and this like targeted analysis and what we actually do in the product security, application security space doesn't go to this level. And I think we're missing stuff. I know that we are, because we're not using all of the tools that are available to us just because we don't know that they exist.
Mm-hmm.
Right. We all come up and, when we start somebody out in application security, we introduce them to Burp and the fuzzing that's built into that. Yes, there are extensions. Yes, Portswigger and other places are doing research and adding to the fuzz list that we use on a daily basis. And some of the bug bounty researchers are as well. But even they don't go to this level. It's all, hey, what have I seen in the past? And does it work against this current instance? It's not what else is available and what is the space that I should be looking at outside of the limited window that we look at on a daily basis.
Yeah, I also think as you get into this, one of the things that is very useful when you're doing fuzzing and is for testing more generally is thinking about all the things you did cover. I think as security people, and Seth and I have talked about this before, as security people, we're very prone to pointing at the negatives. And then when we get to an assessment with zero findings, something I often hear from more junior folks is, we don't have any findings. Like, what do we write up? And it's like, well, you write up the things you did test that seemed like positive test cases. And, as you're thinking about fuzzing, as you're thinking about invariants, as you're thinking about program analysis, whatever it is, it really lends itself to very quickly being like, this is the positive test cases that I can deliver back to a client or a internal team and say, this is what we looked at that didn't seem to have issues. Now, could we be wrong? Could there be other things in here? Absolutely. But at least you have a map of where you went and what you looked at, and it's much easier to start from there.
Yeah. Yeah. And I mean, we always talk about don't make it personal, right?
Yeah.
It's hard to test some of those things that have the basics right. Because you do have to spend more time to find anything. And even then, like giving them kudos for, hey, it looks like you have covered it, and that's okay, right? Like you can generate a report that basically says, we ran all these tools, we sent all of this data at the application, and it did what it was expected to do. But as long as you show your work, basically, you're going to be okay. So Shadow Fiber on YouTube did have a question. Are there any types of projects that ICOS doesn't play well with?
Yeah, so generally abstract interpreters, they attempt to find what's called the width of a variable or the width of a specific state within an application. I'm obviously glossing over a bunch, but basically they try to find how wide a value is. So for example, let's say you had a loop from 1 to 10. The width of that would be the integers from 0 to 11 per se, not exclusively, right? So abstract interpreters work on this width model. ICOS's model is pretty good for use after free. It's pretty good for like, array analyses and things like this. But it does have the same sort of like state space explosion issues that you see. It can get very like as you have a larger and larger program to analyze, it can sort of get caught up and miss things there. Or just not work. So it's useful tactically, but like most of these higher level techniques, there's ongoing research to make it work strategically across like a huge, like Linux, like let's say the Linux kernel, something like that. Yeah. Usually abstract interpreters, when they are claimed to work across an entire large code base, it's usually because they have a very lossy model. So instead of it's 0 through 11, they'll say it's 0 to infinity. And that's it. It's basically all integers. So it's fine. If you're okay with that, then it's fine. So they focus on precision and making sure they're very precise about their findings. So they don't necessarily work or can't find widths for everything that's within an application that's arbitrarily large.
Mm-hmm. Makes sense. Well, good. I mean, Stefan, we've been going for an hour. I mean, the one thing I did want to mention is we should probably, if there's enough interest for this, you and I should put together like a fuzzing for security consultants or for AppSec consultants, right? Like, yeah, at some point we should talk through that, because I do think it's a useful tool to have in your arsenal. And it does push you a little bit out of the web app space, which everybody should. I mean, yes, you can build your career around that, and you can test REST APIs and web apps, for your entire life, I'm sure, if you want to. But there is so much more that's out there from a, mobile app and server perspective and cryptocurrency and everything else that goes into our modern like internet age, that you can actually test with these, and it is approachable. It's just a matter of knowing what the tools are and actually getting some experience with it. That I would encourage everybody to do. But
even within your web app space, though, like let's say you have an application with 10 different URLs and they expect to be called 1 through 10, even understanding the general graph flow. And Seth, this is something you and I have talked about, like a graph theoretic view of web applications. Like, even understanding the graph flow through your application and through a web app, and understanding what URLs are there and replaying them in different order, mutationally generating that graph, can yield very interesting results based on just simply replaying things in a different order, right? So even understanding the basics of these things and understanding the program domain analysis of it is super useful. Yeah, and Seth, to your point, we probably can have a few folks come on and talk about fuzzing and whatnot. And we can pair with Antonio there as well to expand it beyond some of the binary stuff as well too. I think it'd be great.
Yeah. So if you're interested in it, again, jump into Slack or hit us up on Twitter, at Logikill or at Seth Law, and we'll keep the conversation going, because it's, I don't know. I like this side. Obviously, we're kind of geeks because this really excites both of us, and we can talk about it for hours and hours. And we have talked about it for literally hours. I'd like jump in, ask questions. Let's play with it and actually see what we can pull out of it. I'd be really interested to see it turned on other applications, stuff that's internal to companies, right? Just to improve that overall security, but also to expand our current space. So.
Just to drive home the point that we can talk about this for hours, Seth and I spent about 10 minutes prepping for this today. We were like, what can we do? I don't know. I didn't have time because of work and whatnot. And it was like, yeah, whatever. We'll show this thing. And we still managed to pull out like, an hour and 5 minutes basically of content. So there's a lot here.
There's a lot here, and we're barely even scratching the surface,
Yeah.
right? Like, I mean, introducing you to those tools and doing some demos on each of them would be great. Like even using things like GDB as a application security person for crash analysis, it becomes a fairly interesting exercise in understanding your application and what's actually going on. So, good. Well, any other last minute thoughts?
I have so many, but no, I think it's a good place to end there. Just expanding your domain into other areas like program analysis and system analysis like this is super fascinating. And if you are interested in this sort of thing, obviously I have a lot of resources. Seth has a lot of resources. We probably should just put together all of our resources into a document and release that.
Awesome fuzz list on GitHub somewhere.
Yeah. Well, there's awesome static analysis, awesome fuzzers, awesome symbolic executors, awesome abstract interpreters. There's a really there's like a lot of docs on that, but yeah, we can pull together some stuff.
Yeah, it'd be interesting to do our take on it. We've got that Absolute AppSec website too. We could throw it up on there. So
yeah, exactly. Just a whole section on fuzzing.
A whole section on fuzzing, and then a whole section on logging, right? All right, everybody. Thanks for joining us today. We'll post this up soon, but again, appreciate Stefan coming on, stepping into Ken's shoes as he's off gallivanting somewhere, vacationing on a beach while the rest of us slave away.
It's crazy having your boss on vacation.
Yeah, exactly. All right. Thanks, everybody.
Bye.